Hi, welcome to In 5 Minutes. Next problem is again based on PNP type, common emitter configuration. That is example 2, I am writing it as 2. So how to identify again the type of transistor? As I have told you, arrow is always from P to N. So it is PNP type of transistor, or can say PNP transistor. Then which type of configuration? Common base, common emitter, common collector. For this you need to identify which is your emitter. So this is your VEB. We are providing voltage to the base. So when you draw the diode, it will be like this. So you are forward biasing the diode, right? So this, first of all, this is your collector, this is your emitter, and this is your base. Now you are applying input to the base, you are taking output from the collector, so it is common emitter configuration. This is how we can identify the type of transistor and the type of configuration. Now the question tells us to find the circuit shown in the figure. VA they have given as 120 volts, so that implies that we need to consider RO in the circuit. Determine the small signal hybrid pi parameters. We need to find the values of R pi, GM and RO. And finally the voltage gain VO by VS for the PNP type of configuration. To start with, what is our first step? We draw the circuit under DC operating conditions. That is, we remove the AC sources. So this AC source will be removed from the circuit. Then there is no more capacitor to open circuit. So how the circuit will look like? The circuit will look like this. The AC source which was in here is been removed. So in order to find IBQ, what we do? We apply KVL to the emitter base loop. So what will be the equation? Current flowing over through RB is nothing but IB. So I can write IBQ, total voltage. This is negative, this is positive, so we are living with positive sign, so VBB will be positive. With respect to VEB, we are living with negative sign, so it will be minus of VEB, the whole divided by the resistance is only RB, so we will write it as RB. The value of resistance is given, value of voltage source is given, VBB is given as 1.145, VEB if not given, we can take it as 0.7. VB is given in the question as 0.7. Then divided by RB. RB is given as 50 kilo ohms. So this will give you IBQ as 8.9 microamp. Once you know the value of IBQ, you can find ICQ, which is nothing but beta times IBQ. What is the value of beta given? 90. So 90 multiplied by 8.9 microamperes, that will be your ICQ, which is 0.801 milliampere. Once you know ICQ, you can find the parameters. R pi is nothing but beta VT upon ICQ. Beta is 90, VT we always take as constant 26 millivolts, whole divided by ICQ 0.801 milliampere. So this will give you R pi as 2.921 kilo ohms. Once you know R pi, can find GM. Equation for GM is ICQ divided by VT. ICQ you know, VT you know. We can find GM as 30.807 milliampere per volt. And finally RO. RO is VA divided by ICQ. You know VA given in the question. VA is given as how much? 120 divided by ICQ, we have found 0.801 milliampere. So this will give you 149.812 kilo ohms. So we have found the AC parameters which was asked in the question. Next point is to find the voltage gain. For that we need to draw the circuit under AC operating conditions. So this is the circuit under AC operating conditions. What we do? We remove the DC sources, we short circuit the capacitors. So this DC source, the other DC source is grounded, that is we are removing the DC sources. Once we remove the DC sources, what we get is the AC equivalent model. This is your base, this is your collector, and this is your emitter. So what we'll do after this, we'll just replace this transistor with the hybrid pi equivalent. So the circuit will look like this. You have base, emitter and collector. Emitter is grounded. In the base you have RB, R pi, GM, V pi. As I have told you in the previous problem of common emitter for PNP, the direction of V pi, GM, V pi, the same thing has been done over here. Now we need to find the voltage gain. We have output voltage VO over here. So I can write VO as, or simply writing the KVL equation first, I can draw the circuit as. Now the current flowing through RO parallel to RC is in the same direction, positive, negative, and we are applying KVL in this direction. So I can write VO as, we are living with negative sign, VO minus GM into RO parallel to RC equals to 0. That is, when you are applying KVL in the output loop, you will get this equation. So I can write VO as GM V pi into RO parallel to RC. Now if I remove this V pi, what is the equation for AV? It is nothing but VO upon VS. So if I get V pi in terms of VS, I can find the equation for AV. So for this, what I need to do? So look at the input. You have VS, RB and R pi, and voltage across R pi is V pi. So by potential divider rule, I can write V pi as R pi upon R pi plus RB multiplied by Vs. So I got V pi in terms of Vs. So when I am substituting over here, what I will have? VO is equal to positive or negative. Now this sign of V pi which we are following in NPN has been replaced with negative and positive. So while writing the equation, you will get this term as negative. So VO will be, this is the important thing what you need to remember, minus plus. As per this will be negative, this will be positive. Because in NPN, purposely I have shown you like this in order to remember IC is flowing in this direction, IB is flowing in this direction. This is flow of IB, this is flow of IC. So how your current will flow? Your current will flow from positive terminal to negative terminal. So here you have negative, positive. In order to make you understand that this sign changes, purposely I had shown the positive over here, negative over here. So while solving, you will get a negative sign over here. So it will be minus GM into R pi divided by R pi plus RB into RO parallel to RC, and which is multiplied by VS. I am taking on the other side. So this is nothing but your AVS. So what is the final equation for voltage gain? I can say AVS is equals to minus GM R pi divided by R pi plus RB into RO parallel to R. So what is final value? You know all these values. After substituting, you should get voltage gain as minus 4.1789. Now how to remember? In common emitter, you always voltage gain as negative. That is, there is 180-degree phase shift between input and output. This negative sign indicates that there is 180-degree phase shift between input and out. So for any common emitter configuration, either PNP or NPN, you will get voltage gain with a negative sign. So for that purpose, you need to remember that V pi sign is depending on the current. Since the current is flowing in the outward direction, the sign will be positive, negative, right? So you need to remember, this is very important part. Thank you for watching.